top, when it's first dropped, the only force really acting on it is force of gravity, and that's 45.4 newtons. And as it falls and it hits the curve, the normal force is going to start increasing, and in turn it's going to start gaining a frictional force.
We can analyze the graph and see while it's going down the ramp, you have an average acceleration of about 9 meters per second squared.
And then when it hits the flat part right around here, then we know that the normal force is going to be equal to force of gravity. So from there, we know what the normal force is as compared to here, where it's kind of hard to figure out. So here, when it hits the flat part for the first time, it has a maximum velocity of 9.63 meters per second. So the kinetic energy right there is the maximum kinetic energy it has. And then that equals 210.51 joules. And then here at the end of the flat part, the velocity is 8.3 meters per second. And so at that point, it's 156.3 joules. And so to take the change in kinetic energy from there, it is 54.21 joules. And so you know that that is the energy that's lost from the force of friction. So that's the work of friction. And then, so you know that's what work equals, and you know what the distance it traveled over that time. So then, to find the force of friction when it was at that flat part, work equals force times distance. And we solve for force of friction. It is 13.4 newtons. And then from there, in order to find the coefficient of friction, we would use the force of friction equation, which is normal force times coefficient. So coefficient of friction equals 13.314 newtons over
3.
So we know the coefficient equals 0.295.
That's how you found the coefficient of friction.